Hello, guys. Welcome to another stream. So this is like the second stream for the day. Um, so um, I almost did not do this live stream, almost right, because down the line I got so hungry, but I'd already scheduled it. So and I don't like going back on something that has been planned unless it is totally um beyond my control. So today's stream is basically we're going to be talking about a very interesting concept in the Rust programming language, and this was something that I kind of came across from a tweet from a guy I follow on Twitter. So his name is Astra Canel, and so I might just go ahead and tag him here so that he gets to see um the tweet. But basically, it was a tweet from him, and I even had to send him a DM, and that I wanted to make a video about this. Right. So let me just tag him. Where's my profile? So this is my profile. Um, okay, I'll go back and come back here. Okay. So copy this profile. Okay. So it was from him. So I saw this tweet days ago, and so I had to send him a DM. I would love to make a video about this. And he said, sure, I could go ahead. So the tweets is just basically, um, you know, it just basically says, he said something here. I love Rust result type, right? It's either an error or a value. And then he goes ahead to say some things about Go, which I don't really want to go into because this stream is not about bashing another language, right? Um, but basically, he ends his tweet with Rust avoids bugs. In this case, by always making sure that you know is either there is a result or um, you know there is an invalid error that must be returned. You must handle both cases, right? So he goes ahead to say it is either this or that. So guys, please, if you're on um if you're on Twitter, please go give Astra a follow. He's a very he's someone I respect when it comes to Rust and all that. But he's very active and drops a lot of tips and some things similar to this, right? So yeah, he he is the reason why I decided to make this video, and coupled with the live stream we had in the afternoon, where we kind of went very deep into what's it called, and we talked about expressions and statements, and we had to look at how we use the iflets to unpack options and all that. We did that with also with the let else, and also did something with the iflet and all that, right? So in that stream, I that was why I mentioned that we were going to be yeah, thank you, Astra, thank you. Yeah, that's why I mentioned that we are going to be touching on this concept inspired by this tweet, and would, I'll try my best to explain it to the best to the in such a way that um, you know people will be able to grasp the concept. So one thing about these two things is that they are similar and it's easy to confuse them. Right, it's easy to confuse them, but I will do my best to kind of break it down such that it's you know after this stream, you leave knowing that you have some knowledge of, you know, what's the, the result type, and what's the option, sorry, the result enum and the option enum does, um, for you. Okay, so without wasting much time, let's just go ahead and I would quickly create a new file. So I'll just call this randoms. Dot, then just making mistakes with my spellings. Okay, and okay, then I'll import it here. So oh, I'll just say option and result enums, and at the top here, comment this out because I'm not using it. So I would import the random, and I want to get all the functions from there and save. All right. So okay, syntax unmatched. Hmm, sorry about that. So this. All right. So yeah, so here we are, and I would just go in my random function in my random file, and I would create, let me just say I'll create a function that I'll make public. So I'll call it random fn. So coming up with a name is always kind of a struggle. So I'll just do a print line and say welcome to this stream. I'll save missing fn for function. Oh, sorry, I missed fn. Can I do that? Okay. So just to make sure everything works, I'll just go ahead and cargo run. Uh, cargo run. I should get. Hmm, okay, what's happening? Oh, okay. So I'm not calling this function yet in the main file. So here I'll call that function because I already have access to it, right? So cargo fmt and cargo run. Exactly. So it says welcome to the stream. So sure that all the file manipulations and stuff that are done, all the file creation and importation and stuff are done, um, works. Okay. So I'll try my possible best to explain this in such a way that it's easy for anyone to grasp. The goal is not to overcomplicate things, rather simplify things and make it easy for one to or anyone to quickly get an idea of the concept, then go on to um, you know go on to understand why we're doing what we're doing, right? So um, once again, I'll say welcome um, to this live stream. And this is my second live stream for today. And today we're going to be talking about options and results. These are enums in Rust. Um, if you've ever been confused about the options if you've ever been confused about how options and results works in Enums, don't worry, I'm going to try my possible best to break it down to the best of my ability, such that you leave this live stream um, at least a better understanding of how these two guys work to enable us, have better code and more resilient code that is less prone to failure, right? Okay, um, so in languages like Java, right, Java or JavaScript, um, null is a common source of error, right? Um, you can you might try to use like a variable that is null, and this can go ahead to crash your program, right? But in Rust, we don't have null in Rust. Instead, we have two powerful enums, and as you guessed, they are the option and the result enums, right? So they help us handle, situations where a value might be missing or an operation might fail, right? So this is how basically they are how we represent them. So option, right, and results have result have t, and so these are just generics. So e represents error, right? So this is how basically represent this. I'll comment this out, right? Just leave it there for purpose of learning. So basically, this the option says basically represents a value that might exist, right? While result represents an operation that might succeed or might fail, but we explicitly need detailed error information if it fails, right? So that's the difference. So once again, this guy represents um, a value that might exist or may not exist. So I'll just add that as comments. Represents exists, might not, right? While this represents an operation that might succeed or fail with detailed error messages when it fails. So yeah, so just had to add that comments there. So basically, these enums help us avoid crashes, write more predictable code, and so on and so forth, right? So let's look at each of them in details, right? So I'll try my possible best to keep today's this stream short. Though each time I say the stream is going to be short, I end up um, going to have streaming for hours, right? But then again, um, let's continue. Okay, so mm, all right, so let's look at the option enum, right? So at the comment here, say option enum, and looking at this guy, once again, the option enum, um, basically option, right, is an enum that represents the possibility of a value being available, right, being there or not, and it is defined like this, right? So we'll still look at the Rust by example book to show what I'm just writing here. So it's defined like this option, and we have t, and in here we have sum. So sum is for where there is a value, right? And I'll say there is a value, and none. So none is we have no value, right? So this is how it is defined. So let's look at the Rust by example. So say Rust by example, and okay, Rust by example. Look at the option. Enum. Look at that. Okay, okay. Let's look at this. All right. Um. Okay, so we can see here. It says sometimes it's desirable to catch the failure of some parts of a program instead of calling panic. Right. This can be accomplished using the option enum. The option enum has two variants, which is none and some. So I think I will go to um, the Rust book. Let me just say option enum Rust. Let's see what we get. Yeah, so Rust. Let's see the Rust book. Let's look at exactly. So looking at this, right, you can see how it's defined, right? So let's just forget about this. So this means public. This means it's accessible. Outside the standard library, right? So, but basically, what we are looking at is this, right? Which I had just written here. That's how it's defined. So we have an enum of that is has the name of option, and it takes a generic, which is it can take any type, right? And it has two variants, which is none, a situation whereby there is no value, and it takes some, a situation whereby um, there is a value, just like I had explained. So if we go downwards, we can see none, no value, some value of type T, and these are the implementations. You can go ahead to like dive deeper into this, right? To try and understand everything here. But there's a lot here, right? But I'm sticking to the basics, right? To the introduction. You can always go back to this to the standard library documentation and you know um, dive deep into this and try to understand. It has a lot of methods too, right, on it, and I think they also have similar methods like with results, but we'll get to that as we go on in the stream. Okay, so the sum variant, right? This sum variant, like I said, means that we have a value, while none means that we don't have any value. So instead of using null, Rust then forces us to think about whether a value is optional or not, right? So now, an example of this, or like a real world use case of this, would be a situation whereby imagine that you're looking for a user in a database, right? You're looking for a user by ID in a database. So in this situation, the user might exist, the user might not exist. So at the end of the day, you want to return an option where you pass the user um, as the type into the function instead of the generic T, right? Um, to handle that particular situation. So let's just look at the code. Let's write some code. So let's say we want to um, we want to check for a user in a database, right? Okay, let me use a different function. So here, um, example. Say this is example use case of an enum. Oh my god, it's calling me by this time. Oh my god. Guys, please forgive me. Hmm. Okay. Okay. Sorry about that. So I had to quickly respond to that. So where was I? So we are looking at an example of how we use the option enum, right, in a real world example. And I said, imagine we are looking for a user in a database, like we are looking for a user by ID in a database, and the user might exist, the user might not exist. So we want to return an option where we pass the user as the type. So I was in process of like adding a comment to look at that code. So example use case of option enum. So let's create a function. So we'd say fn um, find user by id, and this function is going to take um the type of use size. What's happening? God. So it takes a use size, and this use size would return an option. So it will return an option type. So instead of passing t there, we'll just pass our user. So this could be a struct, right? So we'll say user, and in here we'll then go ahead to to do some checks. So this is just like dummy code, right? Um it's not like the actual code, right? It's not like the actual code. So here, what we can do is we can go ahead to say if database dot contains. So let's just contains and pass in that ID, right? If that is available, we want to say some, and in that place we want to pass want to say something like, let's say um database dot um okay, database dot get, then we'll pass in our ID. So I'm just coming up with dummy codes here. But in a situation whereby that does not exist, we use the else block, and we'll just pass none to handle that case, right? So if you take a look at this, so this is just like a dummy code. There is no database or something. This is just me trying to illustrate how we would use this. The things to take note of here is the option that we are returning from this very function, right? And we are either returning a situation whereby we get the user ID, or we don't get anything, and none always evaluates to zero, right? We'll still look at that. So in a situation whereby we find the user, we'll return some. Situation whereby we didn't find anybody, we'll return none, right? So this makes it clear that the user might exist and forces us to handle that case, right? So now let's look at another situation where we want to handle um, so for instance, when we need to check for like you know both possibilities, whether we have a value or not, right? When we want to do something like that, where we want to check for both situations or both um possibilities, right? We can use the match statement here, right? To do that, we can use the match statement and say match find user by ID, and we'll pass an ID to the match statement, and would now do like a you know how pattern matching works, and would match for the situation whereby we found the user, a situation whereby we did not find any user. So let me just write the code. So I'll say match find user by ID, and I'll pass an ID of, let's say, 100, sorry, 200, and then my block of code, and in here I'll say some um ID, right? Exactly, some ID. It can be ID, or I can just say user because I'm getting back the user. So here I will then go ahead and say print line, and I'll say I found the user. So user found question mark, then pass in my user here, and I can just say user.name, right? Or user dot whatever. So this is just like dummy code. And then I can handle the non block, right? So for when there is no value, so I would say um yeah, user not found, right? Um yeah. So by explicitly handling both cases, what we have successfully done here, guys, just forget about the errors that are showing here. This is just for me to be able to demonstrate the code, and for us to understand what is happening, and how to the use cases for for the option, and how we can use them in our code. Right. I had initially explained how we can use them in this function. Also went ahead to explain how we can use them in here, as when we are doing something like pattern matching and all that. But basically, the summary of everything is that by handling these both cases, a situation whereby we found the user and a situation whereby we not find the user, um, we we have, in other words, avoided null, right? We avoid using null, the null value by accident or accidentally, which is a common problem, like I mentioned, in languages like JavaScript and what's it called, Java and the rest of them, right? So Rust also provides some handy methods on the option in one of them is the unwrap, right? Let me check. So this is the unwrap. Yeah, so the unwrap is kind of risky. It's not something that you should use in production, because if the unwrap doesn't find a value, it would panic, right? It would throw an error. So it's not something you want to use in production. So let's just take a look at what they have to say here. So they said returns the contain some value and consuming the self value. Because this function may panic, um, its use is generally discouraged. Instead, prefer to use pattern matching and handle the non case explicitly, right? Or you can call we have the unwrap or else and unwrap default, right? So it is really discouraged to use unwrap in production because it panics, right? It would panic, right? So if panics if the self value equals to none, right? So that's one method that you can find on this. We also have the unwrap or, which is this, and which is more safer. So returns the contained value. The unwrap or, now when it finds none, it returns. I think it returns zero, right? As a value. So here it says arguments passed to unwrap or are eagerly evaluated. If you are passing the result of a function call, it is recommended to use unwrap or else, which lazily evaluates it. So that's the difference between unwrap or and unwrap or else, which is the lazy evaluation functionality, right? Which is something that makes a lot of sense that you might want to think about on using. But moving forward, we can see that it says the unwrap or returns the contained value, some value, or computes it from a closure. So a closure is kind of like similar to um, you know, it's kind of similar to arrow functions in JavaScript, right? Is a way in which you can pass a function into a method, like a map method or something. We'll get to that, right? Maybe in one of my live streams would build like a CLI tool. I think I have a video on my channel where I built a CLI tool. It's from that passes a file, reads the content of the file and all that, right? Um, we can So basically that's what closures are, right? They're similar to like arrows in JavaScript. So I'm just trying to explain what this is. It has a kind of a weird syntax, but when you look at it enough, it begins to really make sense, right? It begins to really make sense, and we can actually even see it here, right? So this is a closure, right? Um, yeah. So basically, um, you know, it says, where was I? So it evaluates the value or computes it from a closure, right? Just like what we have here, and it doesn't panic when it hits um, none, right? It doesn't panic. So it is advisable to use the unwrap or the unwrap or else, or even the unwrap default, right? They all have their use cases. You can always go back to the standard library documentation and you know really dive into these things and maybe try to understand their use cases. Another good way to learn these things is by building with them, right? You have to actually build actual real world working, like real world projects. Watch how other people do it for you to learn, right? I don't think it is advisable to anybody to just go into the standard library and start reading everything line for line, right? You wouldn't even remember them at the end of the day. At least that is my own opinion, right, on the subject. So then we have another method that is called map. I was just talking about that. So we have map. So so the map maps an option to an option. Um, so by applying a function to the contained value. So if sum or returns none, right? If none. So let's just look at this example. So we have sum. So we have a string that is declared on the heap. It goes ahead to use. So this is a closure, right? So here, remember we wrapped this in sum. So the type of maybe some string would automatically be an option type, right? So that's why we'll then be able to call the map function on it because the map function is available on the option enum, right? So we can then call this function, and based on our last definition, we can either return the value by handling it with sum or passing a closure into it, just like they've done here. So what we are saying is maybe sum, whatever is in maybe sum is what we have here as s, right? So go ahead and give us the length of s. So s dot length will return the s. So as you can see here, um, you know, when this code is run, it will give us the length of hello world, right? I can even quickly run this, and let me just run this in my code and show you guys. I'll comment out these guys, and I'll put it here. Just put it inside here. Okay. Um, so let's, and I would say take out this. Say length. Okay, and then maybe then. So let's run this code and see. Okay, so I need to pass. Let me see. Okay, let's run this code and see. So you can see, right? It has the value of 13. So hello world is 13. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we have it printed here in the terminal, and of course wrapped in the sum value, right? So yeah, so this is basically closures, kind of similar to arrow functions, right, in JavaScript. So let me see. Arrow function in JS versus closures in Rust. Let's see. So we have this. I have this stuff that uses generative AI. So in JavaScript, an arrow function is a concise way to write a function expression, while in Rust, a closure is an anonymous function. We know that arrow functions are also anonymous functions in JavaScript, right? Unless they are an expression. But is an anonymous function that can capture variables from its surrounding scope, essentially serving a similar purpose to arrow functions, but more explicit type management and a significant different syntax. And both are used to create small flexible functions that can be passed around as arguments to other functions. Right. So at the end of the day, it just goes back to what I had said initially. It's kind of similar to arrow functions in JavaScript. Right? If you're coming from JavaScript or you have previous experience with JavaScript, and closures, though they have different syntax, kind of a little bit weird. If you're seeing it for the first time, by end of the day, it's the same thing, right? It's kind of like the same thing, just a difference, like just like it has mentioned here, explicit type management and a different syntax, right? So it goes ahead to say the arrow functions use equal to and greater than sign symbol in JavaScript, while Rust closures are more verbose, um, um, uses a more verbose syntax with vertical bars to define the parameter and capture variables, right? Then there is this stuff about type inference and this keyword behavior that we're not really going to look into. But comparing them side by side, we can see this is JavaScript arrow function, right? Um, and this is how closures are, right? At the end of the day, it's just the same thing, right? So X here is an integer type of I32, same for Y, and we are then using it here. So this closure is going to return an I32. So it's going to take those two numbers and add them. So if it's 10 and if x is 10 and y is 5, it will add them and it would return an I32. It's going to return an I32 for us. So it's going to return the value, right? Whatever the value is. So it's going to return it. So in this case here, we can see that the result here was they called it and they passed 5 and 3. And it captures those values from the surrounding environment and then does the computations and returns a value. So this is like an expression. And um, if we print this, we would get 8, right? So it's similar to what we have here too with the arrow functions, right, in JavaScript, right? So yeah, I don't want to digress so much, but it's always important. I always find it necessary to do a side by side comparison with a language that is very popular among developers so that you can begin to see that whatever concept you've learned from a different language is easily transferable to to Rust. Because at the end of the day, the basics, right, they don't really change, right? They don't really change. So that's why it's always advisable for one to really learn the basics, because it will help you in the long run or on the long run, whatever. So let's continue from where we stopped. Um, okay, so I just showed some examples of this. We don't have to go ahead and start writing another code, but what I can do right now is maybe we can um, write our own small example of how we can use something like the map, right? So that we get like a look and feel of it, right? So I would say um, let's number, so let number be equals to sum, and I'll say this is 10. So you can already see that I'm using Rust Analyzer, and it has automatically inferred the type of number for me. Right? It has automatically inferred it that number is an option type of I32, right? So it's an option type of I32, and this is because I use sum. And Rust, this sum is a variant that is contained in the option type, right? So Rust knows to infer it for me, right? So it infers it for me here. So there's a nice feature on Rust or VS Code where if I click on this option twice, it says here double click to insert. Right, so I can double click this and it inserts it for me. Right, so I have this long weird stuff. So I don't really like including it, and it's the reason why I still use Rust Analyzer and all that, especially for these streams because it makes it easy for me to understand what I'm doing, understand where something is breaking before even going ahead to compile the code. So another thing I can do, I can select num and I can manually or explicitly, you know, add the types. I'll say option. I'll give it a type of let's say type of bool in this case, and I would now say sum, and I'll pass through here. See, are you close it? This. So this is So let me just call this boolean. And yeah, so you can see I manually explicitly added this myself, right? It's um it's still a way you can it's still something you can do, right? Like manually adding it yourself or just going without it, right? But in my case I use Rust Analyzer, so it tells me the type, right, that this variable is. So this variable is an option type of I32, and I32s are integers, right? It's an integer type in Rust, right? So I'll just go ahead and comment out this line. So it was what is showing that. Then I'll go ahead and try to use our map um, method, right? Because remember we have the map method that is available on the option type. So I'll go ahead and say let's double this. Let's double. So I'm using double because I want to multiply it. So I will say um, number, right? So number dot map. So you can see all the functions that are available on the option type, right? There are a lot of them. Most of them I don't even know. At least I know of iter for iterating, and there is iter mute, so for iterating and mutating. then we have the map itself, right? So I'll just go ahead and say map. And I know that we know that this map, based on my previous explanation, we know that the map takes something similar to an arrow function, but in Rust we call it closures. So here I will use that to capture the variable which is number, right? So I would use this and I'll pass something like x here. I can use anything x, n, whatever. Then outside it, I'll say x multiplied by 2, right? And I'll end it with that. And if I go ahead and I um say doubled, I'll change this to doubled, and I save. And okay, so I should have when I run this, when I build the code, I should get 20, right? Because x here is now representing 10, 10 which was passed into this number variable, and we are now using map on number to capture using closures to capture that value and multiplying it by 2, right? So closures, like I defined initially, is just a way to pass small functions into other method, right, and do pretty amazing things similar to the way arrow functions works in JavaScript. So I'll go ahead and run this code. I'll go run, and you can see, right, I have 20 here, right? So basically, if a value is like this, like sum of 10, map would go ahead and multiply. But if it is none, map will go ahead and do the unwrap or, which gives us a default value of 0. So let's look at an example of this just to see what unwrap order gives us. So let's say let none be equal to none. So let's unwrap none. So unwrap all, right? So so I'll just leave it like this. Save, and I'll cannot find the default. Let's go. What's this there? So exactly. So the default. So here I would say instead of okay doubled, and I'll say none. None. Save. Exactly. So we have 0 here. So let's go ahead and look at enums. So I'll try to be a little bit fast about this. So let's say we want to read a file, right? Let's say we want to read a file. We know that the operation can fail due to issues like the file not existing, or maybe we have like potential permission problems, or basically we cannot just pass the file, right? We can't read the file, right? Um, these things are like IO operations that can fail, and this is where results comes to the rescue, right? So, to demonstrate this, we are going to import something from. So I'm going to comment this out. So I'm not using it. So that was just like an example to show the definition of how an option in works, right? And I don't think I did anything similar for results. Okay, did I? Was supposed to do something. So I will just go ahead and do something for the results. So results, you know, what's happening. Okay, so I will say enum, and I'll call it result, and here it will have like T and then E for the error, and it returns okay, right, and ER, right. So this is like the definition for an enum, right? So I just put it there for um just basically for the purpose of learning, right? But back to where we are, what I was talking about. Um So the enum in of itself, like I said, it's how we handle like IO operations, right? It's used for an operation that would either fail or sorry, a situation that would either succeed or fail, right? And when it fails, we want to get the error message. Like we want to get an error response. We can call this like user experience, right? Having like user experience, like you understand. So for a situation whereby you are trying to read a file and the file fails, you want to tell the user what happened. Like why did that file fail in the first place? What happened, right? So that's where this comes into place. And we already did like the definition here, right, for an enum. So we can even go ahead to type here, we'll add e. We can even go ahead to so we say this success contains values and this failed and contains errors. Right. So yeah. So we can even go ahead to look at results in Rust. This is it. So exactly. So just as I've defined it, so we have the enum results, and then these are generic types of success. That is the content and the error message. So return okay if it's successful, return errors if it's not. Right. So it goes ahead to say the result is a type used for returning and propagating errors. It's an enum with variants of okay, representing success and containing a value, and an error which represents error and containing an error value, right? So functions return results. What have I done? So functions return results whenever errors are expected and recoverable. In the STD crates, result is most prominently used for IO operations, right? So it's most prominently used for IO operations, like reading a file and all that, right? So you can go on and on and on and read more about this if you want to really geek away on this. Another thing again I can look at is the methods that are defined on it, but we'll still get to that. So we still have the unwrap, have the unwrap error, we have the unwrap or we also have what else? So these are like some of the methods we have. We have inspect, we have flatten, we have the map. Right? So these are methods we saw on the option type, right? We have map from option. We also have the unwrap or and the unwrap and all that. So they share similar methods, right? They share similar methods. So let's say we want to read a file, right? Let's say we want to read a file. The operation can fail due to, like I mentioned before, let's say the file is not even existing or we have permission issues. That's where we would need to use the result type, or that's where the result type helps, right? So in order to do this, first off, we have to import something, right? So we have to import the file system from the standard library. So say use std, go to fs, exactly. So fs, save this. Okay, so I'll comment out this guy because I'm no longer using it. Hmm. Okay, so down here, I will create a new function. So I'll create another function and I'll call this function read config file, right? So I'll say fn read config file, and it's going to take a path, right? So it's going to take a path which is going to be a string slice. So path to be a string slice, yeah, and it's going to return a result, right? So say result, and we know that our result has two values, right? So in this case, we know that our path is going to be like a string, so the name of the file. So we'll just pass. string, and here we'll then handle our error. So we'll do std io, and we'll pass in our error. So e, so we have error here, and we'll close this, and the curly brackets. That's for that block. Yeah. So inside here, we'll now go ahead to use this guy, this fs. So guys, also note that this stuff that I did here is not necessary, right? I can do it at the top. I can cut this and do it here. So I'll say use this, close it, and here I will just pass error, right? I can do this and it will still work. It's still the same thing, right? It will still work. Um, yeah, let me see. Mismatch type, error found, unit type. Hmm. Let me see. Try it again. Expected an enum, std, blah, 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 found. Hmm. Okay, that wouldn't work actually. Or let me see if I did it like this. Uh, so I'm just experimenting here, see what's possible. Here I can say IO. IO plus error. Yeah, still the same thing. So that wouldn't work. Okay, I was thinking that would work. I'll still look at that at a later time. It's weird that that did not work. Anyways, back to where we are. So save this. Uh, okay. All right. So in here we'll say fs, and in our fs, because remember we had imported this from here, so the file system, right? So on that place we have something called read to string, right? So that read to string will then pass our read to string, so we'll pass our path to it, right? So pass our path to it. Yeah, so we can call this function in this in our random fn, and because the reason we can do that is because we made our random fn public, so we can get access to it, right? But we've not gotten there yet. So now, if the file, like if we read this file successfully, right, would get the okay part, right, which will return the string. But if it fails, we'll get an error. So let's just try it. I'm not fully aware that we've not passed any file. So let's just put that function somewhere here. Put it here. Okay. It's expecting a part, so I'll just say let me name Control A, Control C, pass it as a string. Let's see. Results that must be used, results, maybe an error variant should be handled. Okay, I'll come back to that. So cargo run, let's see what happens. Okay. Um, yeah, so I need to use like pattern matching to handle that case. But before I get to that, um I just want to state that if the cargo.toml file does not exist, would it would return an error, right? But if it does exist, we would return the content, right? So it's just like option. But in this case now, it's just like option, but in this case we are returning an error message, right? And we can still use like the match statement to kind of like handle the situation whereby it's either is available or it is not available. So let's quickly do that. So I have the read config file. So I would just append match to this, right? and I'm already passing my cargo.tml file. So here I will then wrap this something like this, and in here I want to handle the OK part. So OK part, I will just call it contents, and so I want to print line. I would say content. I don't know what's happening to me today. Content, and then I want this. I'll just pass my contents here, right? And so for the error parts, so I'm still getting that error because it's saying missing error, so it's not covered yet. So I'll then go ahead and do error, and there I would pass just E, which is for the error type, and I would print. So just print error type of E, right? Yeah, so this should have handle the both cases for me. So save, and let's run this code again. So you can see that all our errors and our problems have now disappeared. So let's just go ahead and do cargo run and see what happens. So you can see that I just successfully read everything that is inside the cargo.toml file, right? So I'll reduce this, and if I open this file, you can see the things I have here. So you can see in my terminal, I have name, which is first of all, I have package. This is the online one. Then I have name, Rust by example 2, which is this on line 2. And I have the version, which is 0.1.0, which is on line 3. And I have the edition and I have the dependency, right? So this is for the case whereby the content is available, right? We are handling the successful aspect um, of our code. So what if so for some situation I misspelled the name of um the file. So let's say I added double zeros here and I try to run this code again. So it will give us an error message. So it's now telling us that there is no such file in our directory, right? So there's no such file in our directory. I mean, we can even read the file that we are currently working on, right? So, but you can see how it handles that error for us. This is the difference between the results enum and the option enum, right? If it's the result enum, you just return zero, none, null, or not null, just zero, which is none. So it's a silent. I will call it like a silent response, right? I wouldn't really speak to anything. But in the case of results, like when we're handling like kind of like IO operations, like in this case, it would return an error message telling us that no such file or there is no such file or directory, right? So we can even go ahead and read this file that we are currently writing code for. So we can say random s rs and save, and I will just increase my terminal, right, and reduce this. So when I run this code, cargo run, okay, I'm still getting no such file. And oh, okay, this is not in the root, so I have to do something like src slash random. Let's try that. See, still no such file. Let's see once again. This should work. Hmm. See. Hmm. Okay, that's random, not random. Oh my god, what's happening to me today? Randoms. Okay, that's rs. Let's run this again and see what happens. Exactly. So this is all the code that we have been writing, right? Starting from the top where we have use standard FS, and we kept on going. So everything in this file, right? We just read it to the terminal, right? And you could immediately see how we are getting series of errors that no such file existed until I found out that I made a mistake and I wrote M instead of N, right? So yes, this is how we could how we can use the result type. There is also something else, right? That we can do. Um, we can use the question mark operator to write cleaner error messages or to handle cleaner error propagation. So instead of using match, so this can be really exhausting, right? Writing match all the time. So instead of using match, you can use the question mark operator. So let's look at this. Hmm, okay. Yeah, okay. So try this operator is used to return errors to the caller, right? So it's used for error propagation. I'm looking for um like something that would explain that for us. Okay, so this is for error propagation, right? So on the question mark operator. So we use it to propagate the errors back to the person that actually called the function itself, right? In this case, it's going to be like the parent itself. So I'll write like code for this, and you see how simple it can be, right? Compared to the match statement that we did. So let me see if I will see any place here that they used question mark operator. Okay, there's nowhere. Let's just go back here. So now instead of doing this, so I'll just comment this out, right? And I'll write a very small there's no need of even writing a function. I'll just say let content, right? Let content be equal to, so we'll call that function. The function is read file config, and we'll pass our file path. So we'll just copy these guys and pass them into here, right? So we know that that's our path, and we'll end it with so this time around, instead of doing our matching, we just put a question mark here and end it with a semicolon. So that's like, okay, cannot be used in function that return. Oh, okay. So yeah, so that makes a lot of sense, right? I will get to why this is breaking, but we can only use this question mark in a function that returns, as he said here, that returns a result or an option type, or implements the from residual traits, blah blah blah. Okay, so it says this function is not implemented for an empty tuple. So this is just long grammar, right? And the solution to this problem is this our function, and which is the random fs. You just have to come here and return a result type. So I'll say results, and I will call this content, and here I will pass in my std standard io and error, and close it, right? So this should solve our problem. So if I save this, cannot content is not okay. Cannot find content in the scope, not found in the scope. That should be parts, right? Should be parts. Let's see. Expected type written part not found. Hmm. Am I getting these errors? Oh, it's contents. Okay, I think it's string smash type. Sorry. Sorry. Contents. cannot find type content in this scope, not found in this scope, random access. You might be missing the parameter content. Oh, okay. Uh, hmm, okay. Load config results type fn. Okay, so let's do something different. So I'll take this out from here and I'll write a separate function just to handle this situation. So down here I'll say fn load config, and here I'll just pass my result type, and then I'll say config, and I have my standard library IO and error, and in here I'll just select contents because to this, and so the OK parts to undo the OK, I'll just pass my config, right? Config, um pass, and then the content. So say undo, sorry, config, um to pass this, then reference to my content. So I don't want to take ownership of it. Save, get the result undeclared. Cannot find the config type of one. This not in the scope. Let's content file, blah blah blah. Expected config. Okay, so let me run this first and see what the compiler will tell me. Could not compile due to previous errors and warnings. Okay. Use of undeclared config. Oh, I see. Oh, I see. I see. I see. I see. Hmm. Okay. So you might be using a type parameter. Okay. Function load results. Okay. Okay. Hmm. Okay. So I'm still trying to understand what I'm missing here. Uh, okay. Have these errors. Cannot find use of declaration type. So I pass the config here, and okay, okay. Cannot find this one down on line 57. That means what I had done initially would have still worked. Um, okay. Hmm. Hmm. Okay. trying to understand why I'm getting those errors. Okay, I think I might have forgotten to. Okay, okay, let me do something. So I'll create a struct that I would call config, and this struct is going to take contents and it's going to return a string. Okay, fail to resolve scope. Okay, okay. Then I'm going to write an implementation block on that. So implement config, and here I'm going to write an associated function I'll call pass, which is this guy here, config.pass. And what this function will do is it will take the content as a string slice, and it will return the contents of the string. Like it will return the contents, and I'll change it. Like I'll make everything to be returned as a string. Right, so it will return the config at the end of this. So I'll say pass, and this will take contents. Mhm. This content is going to be a string type, and it is going to return config. And in here, we just say config return contents. Contents. I have to remove this contents, and this is well over 1 hour. Okay, contents dot to underscore string. And so save this. Okay. Yeah. So here in my load config, I'll return a result type of config that takes a the error standard IO. So okay, so this expected and syntax. Why is this smash type in result config? And why am I still getting these errors? Hmm. Read file type. So I have my read file type, and my read file type takes the paths, which is a string. Mhm. Okay, so let me just unify everything to one place so that's easier for me to. Okay, I'll put it here. Not here, put it at the top where we have everything together. So this load file, we have return results, config, standard IO library, standard IO dot error. So let's contents. Hmm, okay, so I have okay config pass content. Hmm, okay. Hmm. Smashed enum. Okay, so again, save this. Let's name this. Hmm. Then in what am I seeing? Why am I finding unit type? This is not a unit type. I passed. Am I missing? Am I missing? What am I missing? Hmm. Okay. So I'll just step through this code one after the other to try and understand what I'm missing here, right? So first of all, I have the file system imported. Then I have my struct, config, I have content string, and then I am also I created an associated function, right? So passes the contents as a string slice and returns the config. Mhm. Okay, then um, let me take this out and see what this will give me. Okay, so then I have my load config, and in my load config, yeah, I'm returning the result type and the standard IO error, blah blah blah. So the contents, and from my contents, I as the string type, I'm calling the read config file. I'm passing my file, and then okay, mhm, pass then the contents. Okay, then I have my function read config file path string. It returns a string. Okay. Hmm, okay. So here I want to pass the okay. Let me see what happens. Cannot function okay in this scope. Yeah, that's because um I'm not using my let me comment out this guy. Let's see. Hmm. Oh, okay. And so here I have to and because I have to put my result, and it will take this. So it's going to take this standard IO error, and here I'm just going to pass out my config. Oh my god, you won't believe what I've been breaking this code. So I accidentally passed this here. So and one thing to take note of is so when you pass like a semicolon, it becomes a statement that just ends in that line, right? It doesn't return anything. So that is why I found that's why I was getting a it was telling me expected result config error blah blah blah, but found um you know an empty parenthesis. And this is because the reason this happens, at least to the best of my knowledge, is because by passing the semicolon, I had made this a statement instead of an expression. So it doesn't return anything. So it returns an empty this thing. But when I take that out, it then returns. So it doesn't just compile and end here, but it ends up compiling and returning the result type of config. So this is the error I made, right? I added so these are like the little trivial things that can really mess one up. So I spent like quite some time trying to figure out what I was doing wrong. To be honest, I could not even understand where the error was coming from until I found out that I had added a semicolon here. So that's something to watch out for. These things happen from time to time. Yeah, so I'll take this out. I don't really need that guy. Oh, yeah, I don't. Well, let me just leave it there. Save. And cannot find okay in this scope. Yeah, that's understandable. And the reason is because okay, let me see. Unfind. Okay. Ah, yeah. So the reason for this also is because I'm using a small letter, right? So these are things that you have to look out for. So if I save it, yeah, that error goes away. So yeah, so it's yeah, coding can be like this sometimes, right? Where little things can really, sweep you off your feet, just like what happened to me now. And once again, I'm going to explain why I was getting that weird error message. What line is that here? I was getting that weird error message because this became a statement, right? So it's just compiled and ended here. It didn't return anything, right? And but if you want it to, especially when we are is wrapped in this block, like the two curly brackets. So if you want it to return something, you have to take off that semicolon, and only then would it be able to run, and you get what you like, the actual result of what you're looking for, right? So back to where we were trying to run the code without using the match and just using basic error propagation. So right now um I can take out this guy. So I can just take out this particular line of code and take it into my what's it called? Um I can take it into my function, the random fn function, and run it in just one line, right? So this question mark here does error propagation for us, right? In that we won't or we don't necessarily have or need to use a match statement. The error is going to be propagated to the parent or to the function that made the call, right? Also, don't forget to add question mark here. See. And the operation can only be implied to the value that implements the try. Implement try. The try is not implemented in config. Okay, so the try traits. Yeah. Okay, guys. So basically, yeah, I know I've not done enough justice to my explanation for this, but that was because of the bug that I faced along the line. And yeah, so these are one of those things to expect when you're doing like a live stream, and one should always like get ready for them. But basically, the question mark operator helps to propagate errors up the stack without needing to have like a long match statement, right? We don't need to have a long match statement, so I could um like I said, cut this out. I could cut this and then take it here. Comment this out and save. Um, expected this found config. So I'll add my this inside to yeah. So you can see the error that I found there, right? So expected but found this. So here mismatched types. Um, so I can pass my config here. So the config which I defined. Let's see what happens. Expected config but found this. Oh, let me take this out again. Okay, yeah. So yeah. So um, yeah. So I've just been fighting the whole error stuff, but basically, right? Um, it's more private than the item random fm blah, 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 and the default. So just the warning and stuff. But basically, what to look out for is this, right? Comparing this to, so let me take out this. Right? Do I want to use this guy again? No, I don't. I don't. So I just did this out here just because I needed to do a couple of testing and all that. Right. So I created a config, a struct, and a struct called config with content type of string, and then you know wrote an associated function for it that does the passing and all that. Right. But at the end of the day, in order for me to be able to propagate errors to the random function, I just pass a question mark at the end, right? So after doing that, I'm now calling the config.pass. So I'm calling the config.pass. I'm passing the contents to it. So it's going to pass the contents here, and I'll be able to you know um I'll be able to go ahead and you know, use that code. So if something fails, right, an error propagation will just be done for me automatically. So let's look at like key differences, right, between the both of them. So scenario whereby you want to use options when you're, for instance, searching through a list, right? You're searching through a list, or maybe um, a vector that contains arrays and stuff, right? Um, that's like a situation whereby you want to use a list, but a situation whereby you, sorry, an option, right? That's when you want to use an option. A situation whereby you're doing anything that has to do with an operation that might fail, right? So, for instance, you're reading a file just like we did, and you need errors. You have to use, the result enum. So, like I said before, both of them require you to handle all cases. So either you handle the sum or none for options, or you handle the okay, right? You handle the okay or the error for results, and also that between options and results, right? I think there's okay. So this is it. So this function transforms the so it transforms option into results, right? Mapping sum v to okay and none to error dot with the value of error, right? So I don't know the use case where this might be used or where you might want to use this, but it's something that is worth knowing, right? Then it goes ahead to say argument passed to okay or are eagerly evaluated. So is it evaluated eagerly? But if you want to lazily do it, just like we saw with unwrap or else, that lazily does the unwrapping, you can do a lazy unwrap. So if you're passing the result of a function call, it's recommended to use the okay or else, which is lazily evaluated, right? Yeah. So guys, that's basically it. One thing to note is that um avoid using unwrap, right, in production environments because it would always panic. And when I mean by panic, it will cause your program to crash, which is something that you don't want to happen in the first place. So you can always use the unwrap or, which is this, or the unwrap or else if you don't want it to be eagerly evaluated, you want it to to be lazily evaluated. You can use the unwrap or else. You can use match, like I said. Also, another thing for you to avoid again is expect. So let's look at expect. I should expect. So this is it, right? So returns the contain some value, consuming the cell value. It panics, right? If the value is none, it's custom panic message provided by the message. So anything that will make cause your program to panic or cause your program to crash, basically, you have to avoid that. So it is better to use things like match. So where is match? It's better for you to use things like match, unwrap or the question mark operator, right? So there's the question mark operator. I can't find it here, but these are the things that you should use so that you can be able to handle error safely. Um, yeah, so I think that's basically all. Um, you know, that's basically all, and that like this will bring me to the ending of the options and results. And like I said earlier on, these are enums that are the core of Rust safety, right? Right, safety features, and I hope I've been able to do my best explaining the way they can be used and how they work in different situations and giving like practical examples where you want to use them. So thank you guys for joining me on this one, and I will see you some other time. Cheers, peace.